We often take the air we breathe for granted, an invisible ocean that cradles our world, sculpts our landscapes, and sustains every living thing. It's the silent force that dictates our weather, the limits of our flight, and even the sounds we hear. What if it pressed down with twice the weight, twice the volume, twice the profound influence on everything we know? And let's find the answer to the question, what if? Imagine a sky forever changed. With an atmosphere twice as thick, light scattering would be dramatically amplified, cloaking the world in a permanent haze. Direct sunlight would be a rarity, replaced by a muted, diffused glow that casts some regions in eternal twilight, profoundly altering our visual perception and the very colors we see. This increased atmospheric mass would also act as a colossal blanket, significantly amplifying the greenhouse effect. The planet would transform into a warmer furnace, leading to non-existent polar ice caps, drastically higher sea levels, and a pervasive humidity across most land masses. Furthermore, this denser air would lend colossal power to winds. Even a gentle breeze would become a forceful shove, while major storms would unleash devastating, continent-reshaping energy, accelerating erosion, and fundamentally altering geological features across the globe. Life's evolutionary journey would be dramatically altered under this pressure. Flight would become significantly easier, potentially leading to the evolution of genuine giants of the air. Wing designs would radically change, prioritizing vast surface areas for lift in the dense atmosphere, allowing for more efficient gliding or powered flight even for larger creatures. Respiration presents a unique paradox. At the surface, breathing would be remarkably easy due to higher atmospheric and oxygen partial pressures. However, ascending to higher altitudes would become an extreme physiological challenge, demanding specialized adaptations to cope with rapid pressure changes. For the plant kingdom, a dense flora would emerge, adapting to the muted light and amplified heat. Plants might grow unusually tall to reach filtered light, or form vast, low-lying photosynthetic ecosystems. The increased CO2 could fuel remarkably robust growth, yet flora would simultaneously require specific adaptations to flourish in consistently higher temperatures and humidity, crafting a world teeming with unique biological strategies. In this world, sensory inputs would be profoundly rewired. Sound would amplify dramatically, traveling further, faster, and louder through the denser air. Distant geological events, massive storms, or the movements of large creatures would become audible across vast distances, potentially leading to sensory overload for some species and completely altering communication strategies. Meanwhile, persistent atmospheric haze or scattering would muffle vision, reducing reliance on long-distance sight for navigation or hunting. Conversely, the constant sensation of moving through dense air would heighten tactile senses and other forms of haptic perception. Finally, the increased air resistance would create a curious gravitational illusion, making falls feel slower and significantly less impactful. This altered perception would profoundly influence the evolution of locomotion, biomechanical stresses on bodies, and how intelligent species develop physical interactions with their environment. In a world defined by immense atmospheric pressure, engineering would evolve radically. Cities would feature resilient aerodynamic structures, prioritizing deep foundations and streamlined forms to withstand constant wind and pressure. Flight would be dramatically reimagined. Traditional aircraft would struggle against fierce drag, paving the way for buoyant airships, ground effect vehicles, or specialized heavy lift craft. Reaching space would become an unprecedented challenge, demanding revolutionary propulsion. On the resource front, abundant atmospheric gases like nitrogen and oxygen would be easily harvested, yet adapting agriculture to a persistently warmer, wetter climate would necessitate innovative controlled farming techniques or the development of specialized, resilient crops, highlighting humanity's incredible capacity for adaptation. This drastically altered Earth presents a profound choice for life: a great filter or an unprecedented cradle. A thicker atmosphere would offer exceptional protection, effectively shielding the planet from smaller meteoroid impacts and harmful cosmic radiation. This enhanced cosmic defense could significantly reduce devastating events, fostering a more stable and prolonged environment crucial for the early development and sustained evolution of life. Volcanic outgassing would play an even more significant role, contributing substantial amounts of gases to the already dense atmospheric composition, potentially accelerating the buildup of vital compounds. Crucially, the sheer mass of this atmosphere would dramatically hinder atmospheric escape, effectively trapping these gases and stabilizing the planetary environment over immense geological timescales, preventing their loss into space. Ultimately, this unique world sets a distinct evolutionary evolutionary trajectory. Intelligent species emerging here might evolve to be slow-moving, incredibly robust, and highly adapted to a high-pressure, low-visibility environment, perhaps relying more on sound or touch. This could lead to societies and technological pathways utterly alien to our understanding, shaped by their deep protective atmospheric cocoon. Doubling Earth's atmosphere profoundly reshapes climate, life, and civilization. In your opinion, what if Earth's atmosphere was twice as thick? Share your thoughts in the comments.